see into the person you're interrogating, but all they see is a reflection of themselves.
Yeah, I've seen those fish
Yeah. Well, now you know what they are. Next slide, please. Oh, they are also used in some cars. Oh, next slide. We have video of how they're made. What? What? Oh, yeah. Oh, and I have my joke. Why is life that fire? Cars grew into my
Okay.
Anyway, video.
Okay.
Kriti, just for
We'll play
move to
the-
this type of the mirrors. Yes.
Yeah, play the
Kriti,
video.
show the demo. Kriti.
Type of mirror. Plane mirror. Plane mirror, like this one. Can you see your reflection in this?
Take it closer.
Can you see your reflection?
No?
Can you see your reflection? Can you see your reflection? Well, you can see your reflection. Same distance as you are from the mirror. Same distance as you are from the mirror. Are you able to reach out and touch it? Are you able to reach out and touch it?
Okay, Kriti, move on. Kriti, show him that. Kriti, Kriti, show them how it reflects. Yeah, show the demo with that.
Right, so if you want to come closer, you can explain a lot better. Explain a lot. Bring them closer.
Come closer.
No, it's okay. Just explain. So in the plane mirrors, I is the incident ray and R is the reflected ray. So if you see the light, right? If you pass the light at 10 degrees, then it is gonna reflect
20.
You see how it reflects? But then if you switch the plane mirror with the concave mirror,
Oh, by the way, I have something to do. Okay, can you see your reflection in the mirror? The inversion.
yeah, upside down because
Upside down? Yeah, that's because what you are seeing is down there, down here, here, and then to your eyes. So that's why it is. Now is it upside down?
When I look from here, it's upside down.
so within the if you see your image reflection within the focal point, then it will be erect and it's the same size.
The reason it says upside down here but not here is because here it can actually it is something wrong. It goes like bouncing through. So the way they
Come here.
come and then they bounce. They meet at a focal point. If you're standing behind the focal point,
So you saw the reflection in the plane mirror, right? So this is how it reflects in the concave mirror. You see that incident ray, when it falls on the concave mirror, it's not going to reflect like plane mirror. Okay, plane mirror you get the exact mirror opposite. In the opposite direction, in the same angle, it's in the opposite direction. Whereas in the concave mirror, it's gonna hit it like this and then come back in this way. It depends on the curvature angle and then the mirror of that. Okay, in convex mirror, the same principle. It's not going to work like in the plane mirror, but based on the curvature, it's going to be
also something else.
different. Okay?
Something else. I've explained
Right,
here.
Karthik.
I've explained it says we really
You see, even though if I try it for 0, it doesn't reflect at the 0. Okay? So that's what is going on. And now he is going to explain the real image and virtual image. Kriti, what is a virtual image? What is a real image?
Frog here.
Okay, once again. Kriti, put it in.
hold it. Can you see the frog? Can you see the frog? Can you grab the frog? Can you grab the frog? Actually, you can grab the frog if you reach inside the hole.
Yeah.
Take the top off. Also notice. Also, if you haven't noticed, look inside. The frog is pointing the opposite direction. You see the hole where it's in. Why is that?
Because
You know?
because when they bounce off their
That's because it is a concave mirror. So it's inverted because there are two mirrors. And so that allows it to.
Kriti, you have the next slide to explain the real and virtual image. Now talk about the size, Kriti. Size in the plane mirror and the concave mirror.
Oh, and size it. Did I ask you, is this the same size? Is this the same size? Is this the same size?
Kriti, you have the convex mirror and concave mirror there. Kriti, there, concave mirror and convex mirror there, next to the telescope. No, not that.
This is concave, right?
Yeah.
Is this the same size?
This is convex, right?
Is this the same size?
Is your image the same size as you? Is it bigger or smaller? Can you go through the reflection?
Is this the same
And does it look closer or farther?
Is this the same size?
it looks far.
That is because they are differently angled. Because even if you are beyond the focal point, even if you are past in front of the focal point in convex mirror, it will be diminished for it. But anyway, there's one spot.
Go to the next slide, Karthi.
Different images.
Reflection by different types of mirror. I told you about the real image. I told you about the real images and the non-real images. Notice where I said, see, it's a real image.
So this is the reason why you have the real image and virtual image. So virtual image in the sense it falls on the mirror. You can see a virtual image. You cannot capture it in the screen. But when you saw the mirroscope, right? The image, the frog is bumping out and you can see it in a different place, right? So if you put up a screen there, you will be able to capture that image. So that can happen only with the concave mirror, okay? So that's how it's explained. Do you see that? Because the image from the reflection of the ray is formed outside the mirror, not beyond the mirror. If it forms beyond the mirror, like in case of plane mirror and convex mirror, you will not be able to see the image, capture the image. That's a real image. Real image, you can capture it on the screen. So only in concave mirror, the image is reflected and it is formed in front of the mirror. That's why you'll be, if you put up a screen there, right in the point where the inverted image is formed, you'll be able to capture it in the screen. Karthi, next.
Real images is virtual.
So this diagram should explain in more. Do you have any question?
Okay,
So in concave mirror, if you see the focal point is front of the mirror. In convex mirror, if the focal point is at the back of the mirror.
then I'll explain it. So, the concave mirror, the image is real if you're standing behind the focal point. Why? Because the image, because the top of the image is usually and where the rays meet. So, if your light ray is going like this, they hit the concave mirror and then they meet at the focal point. If they don't, well, these
Next slide.
at the focal point. So, microscope and telescope. Can you go back real quick? Back. So, it's not,
Somebody asked them what is the use of microscope, what is the use of telescope?
You know the use of microscopes and telescopes.
Telescopes is it to see far things up close, and for microscopes is
Small
those
things.
things even larger.
Exactly. So telescope is to see the larger, farther objects closer. Okay. Microscope is gonna enlarge your smallest objects closer. So
Very
yeah.
specialized microscopes can pretty sure detect atoms. The atom.
So there are different types of telescopes.
Got it. So the way there are many different types of telescopes, but the basic way is it's something to bend it inward to one plane mirror. And the telescope we have here, there's a lens that allows light into a concave mirror, to reflect it onto the smaller plane mirror, or sends it up to the eyepiece. In ours, we have a concave lens, which makes the light ray go to the plane mirror we have here, up to my eyepiece, right here. So I can angle it right.
So you have different types of telescopes. What happens is there is a concave mirror. You see that, right? So the distance object falls on the concave mirror, and then there is a plane mirror here in the 45-degree angle. Okay, so that gets a reflection of it, and since it's aligned at 45 degrees, then you put up a lens here with the eyepiece. You will be able to see the distance object.
Oh, so when you look through, there's a mirror right here. When you look through,
Yeah, that's how it works. And then for microscope, you use the plane mirror and the lenses. Lenses are which is like glass. Yes. So you have, these are the magnifying lenses, convex lenses, and then this is the plane mirror, and then you put up a light, you have the specimen there, then you will be able to magnify that lens. Like you want to magnify it 200 times, then you use that lens. 450 times you use that lens, and then 100 times you use that lens. And then this plane mirror is going to help you reflect light on your specimen, and you will be able to see it close. Okay, this is the microscope. So microscopes and telescopes, they use mirrors. Next.
Next slide, please.
Okay, heliostat. So this is one important, yes.
And so the larger the magnification is, the bigger the object, the specimen comes on.
Yes, very good point. Have you heard about heliostat? Okay. Give us an example of renewable energies. Pratik, example of renewable energies.
Like the radio stations where they give up all the songs and stuff.
Okay, renewable energy. Like now, how do you get electricity?
The radio signals, the radio towers that are everywhere.
Okay.
Alexa gives radio signals to your phones.
I'm talking about the renewable energy. Like how do you get electricity? Now, they burn fossil fuels. When you burn fossil fuel, you get steam. They use that steam to rotate the turbine, and then the turbine generates electricity. Right? That's how it's happening today. That's not the only one. The other renewable energies, but if you burn fossil fuel like coal, it's gonna run out soon. And when you burn coal, you have like a lot of pollutants. That's why you have the global warming problem. Okay, the carbon dioxide, the level of carbon dioxide emitted because of the amount of coal being burned is tearing our ozone layer. Okay, the ice is melting in Antarctica, in the Arctic places. Okay, so if the ice melts, that's it. Like the whole Earth will get covered in water. The whole planet will go off. Okay. So the alternate is renewable energy. Renewable energy is, what do you mean by renewable?
And you can use that can be used over electricity.
Exactly. So what, can you give me examples of renewable energies? Which, yes. Sorry? Trees, okay. I think you want to say wind. Wind energy, yes, that's a very good example. Solar, very good. Yeah, solar is light, okay. Another one. water, hydropowers, and, yes, and then geothermal. So where are mirrors used? In the solar renewable energy. So this is in Crescent Dunes, Nevada. They generate solar power, okay? And then this is in Seville, Spain. What do you see there? They are using mirrors. So how do they use it? So I told you they use the steam they burn the coal to generate heat energy, right? So how are they going to use, this is a mini model of heliostat, okay? So what they do is, instead of burning coal, they are going to use the energy from sun, okay? Kritik, come here, hold this 1 second. Can you stop playing? Okay, 1 second, hold it 1 second. So imagine this is a mini model, this is how it works, okay? So in the center, do you see that? This is the turbine, okay? Do you see this? This is the turbine, in the center. This is a huge turbine. So what happens is, whenever the sun's rays falls in, they tilt the mirrors. Okay? So if the sun is coming from this direction, the mirrors will be facing the sun, so that it reflects straight into this turbine place, where the steam is generated because of the heat. Instead of burning the fossil fuel and generating the heat, you are going to redirect the sun's rays and you are going to multiply it, magnify it by using the mirrors, right?
And then when it comes to it, you get the energy.
Exactly. So that heat energy is going to make the steam and that will rotate the turbine, okay? So when you rotate the turbine, the electricity is generated and you extract the electricity, and that's how you transform it in different places. This is how you generate electricity using solar power, and this is called the heliostat. Helio means what? Do you know what helio means? Helios is the
Let me get some history on it. Helios was the old god of the sun from Greek mythology until Apollo replaced him. So the Helios obviously means sun.
Yeah, Helio is the Greek word which means sun. Apollo is the Roman god of sun. Helio is the Greek god of sun. So that's where you get the word.
Apollo is the Greek god.
No, Apollo is Roman.
Actually, it's both.
Roman, okay? So you understand this, right? Do you have any doubt in this? This is how each single solar panel looks like. You see, can you imagine the size of it? So, you see the small rectangle there? That's what it is. Single piece is this huge, okay? So based on it, you change it based on your sun's rays. Next, Karthik. Do you have any doubt about solar energy? Next.
Then we have some more here. Venus.
So
For flame mirrors, they can be used for.
yeah, usually you check. What do you use the plane mirror for? Yeah, how good you look. Oh, my style is good. Like my hair is perfect. I need another layer of lipstick. So this is for main use is vanity, right?
Yeah.
And then to increase luminosity. How do you increase luminosity? Okay. So say this is your regular ball light, right? You see the brightness getting increased. The same concept with the solar panels, right? Heliostat. If it gets reflected, based on the laws of reflection, it gets increased. In your car headlights, if you see there is a bulb, but then around it you see a concave mirror-like structure. Why do you think they use it?
So the lights are illuminated better.
Exactly. So it burns much more brighter. Okay. So that's one use. Next, let's do periscope. Kriti, you want to explain periscope?
Look at this light. Look at the light in here.
So in military and then other uses, like if you want to spy on something, instead of you can use camera nowadays, but in earlier days you cannot run a power cord or something to operate your camera. You can't be connected to the computer. So this is a simple thing they use. What do? They use two mirrors and then place it in 45-degree angle. Okay, so you can be under the table.
Do you know what this is called?
So say if
Do you know
I'm
what this is called?
say if this is the wall, okay? You can stand behind the wall, so the guy will not be able to see that you are behind the wall. But you can see what is going on there because this reflection.
So I have something to do. I'm behind the TV, but I need to keep an eye on it.
So this is how they use this periscope, okay? Even if they are under the ground, they use it in submarines, they use it in military, and they use for spying and everything. Like this is how they do it. Two plane mirrors in 45-degree angle, and you'll be able to see even if you are on the same surface, okay? Next, kaleidoscope. So what is kaleidoscope? Have you heard of kaleidoscope? Yes.
Are they like those things where like, if you shake them up, inside there's some sort of design and you can through it?
Exactly. So kaleidoscope is a plaything where you have 3 mirrors in a triangle, and you put new junk or colorful beads. Then, based on the reflection, since you have 3 things, you will be able to see beautiful structures. So, what is happening in kaleidoscope? How can we explain it? Priti, okay? Okay, get your structure. How do you explain it, Priti? So, this is what is happening inside the kaleidoscope. There is.
Except on a wider scale. For example, they have
Say
mirrors all
these are
around.
the beads and glass pieces of some structure, okay? See, this is a diamond shape, but then if you put it in 3 mirrors,
Move with it.
yeah. So do you see the beautiful art or thing formed? Priti?
So, this is what happens in a telescope. But on a telescope, it happens on a wider scale because there is no room to the mirror.
So
Take a
one
look.
object reflects and then
You
the
can turn
reflection
it.
of the
Look, really
objects takes an artful form and it's pleasing to the eyes, okay? Okay, we learned about heliostat, and then we use it in dental too. You have seen, right? The doctors, when they try to check your teeth, if they can't go inside, what do? They put up a mirror there. Yeah, and then they'll be able to see. And then concave mirror is used for shading, for a closer shape.
And it's also used in, mirrors are also used in television, things. Concave mirrors are used in,
We learned that they are used in telescopes, they are used in microscopes, what else? Headlights, and then for magnification.
yeah,
And then-
example, if you're shaving one.
In case sometimes you burn things, like say if you are in a forest, you are like Bear Grylls, okay? You don't have a matchstick.
And you need
You
a
don't
fire,
have-
you need a fire, just
But
like,
all you have a concave mirror. What can you
and
do?
then I'm like, all I have is this wait a minute, just like, set a piece of wood on, set a
You
piece
know,
of wood
the
on,
converging property of concave mirror is.
you can set some wood, you
Kati,
can
she
set
has
a
a
bridge you
question.
found on the
No,
ground
I
on
don't
fire,
have a question.
and start a fire using that.
Kriti, she has something to share.
Yeah.
So if you put it at the right angle on like paper or something, the sun hits the thing and it's the material that you have, and then it starts to fire.
Exactly, because all the rays falling and then when you converge it, it has so much of energy because it's all the rays are forming in one
It will
place.
only burn at the focal point because that is where all the rays meet. The focal
Okay.
point is the hottest spot in concave mirror.
And we learned that it's used in headlights, and then we learned about heliostat and then dental projectors. So this is one type of heliostat. Another one is using a parabolic mirror. You have like one mirror which is huge, and then that's used to converge all the solar rays. This is using plain mirrors, but you have another type of solar renewable energy generator where you can use the parabolic mirrors, which is the concave mirror, for the magnification to achieve the same purpose. And then convex mirrors you have seen in the stores, right? They have a convex mirror in the corner. Have you seen that?
Yeah.
So what do they use it for? Yeah, for surveillance. Like if you use a plain
Like
mirror,
a
the
security
vision is
person.
limited.
A
But then
security
if you-
person could look into the mirror and see more than he could see if he was looking
Yeah.
that exact same spot.
So the convex mirror property is you can see the things which are farther, right? But then you will be able to get a better, you'll be able to cover more distance
You'll get a wider scale of
than
view.
with a plane mirror. And then for traffic and driving, in the driving
Okay,
car,
you can't see around the corner.
okay, in the car you have it in the side view mirrors. They are what? Convex mirrors. Okay, so that you can see the cars in the back. Okay. For diminishing and wider view. Okay, next to Karthik. Okay, play the video. So, and another property of the mirror, like if you
Plane mirror.
So,
We had increased luminosity. Look at.
okay, one,
Take a look at this video.
so you see this picture. So you know the property of mirror, right? It reflects. If two things are parallel, and if you do it in the right direction, you will never be able to Kriti, Karthik, wait, okay, before you play the video.
Wait,
So
Kriti.
you will never be able to count the number of images. Why do you
Wait,
think?
This just keeps bouncing.
Sorry,
Yeah,
Kriti,
so
can you
it's
come
the
back?
number of image form is infinity. You can never count because this image, the reflection falls here and then it reflects back and then. So if you see it in the right distance from the right distance, you'll be able to see multiple
Okay.
images. You see it or?
Kriti,
So it depends on the angle you see it from because your eye is a lens, okay? So you need to, if you put it in parallel and if you see it from the right distance, you will, yeah,
It's gonna be infinity.
okay?
It will have no end.
And then this is the better use of reflections. Kritik, show.
Oh, remember, we had
Okay.
Oh, and remember how we said
Show this
increased
one.
luminosity? Measure on this scale.
Yes. Thank you.
We have an infinity mirror there.
Okay.
We're gonna
So do you see this one? Karthik, play the clip again. Kritik, come here. Don't fight with it. Don't push me. So what are they doing? Instead of turning on a light switch, what are they doing?
They're turning a mirror. They're turning a mirror which has light pouring down onto it, and then when it hits the exact right angle,
Okay,
it reflects
Karthik,
off all the other mirrors.
play the clip again. I want one of you guys to tell me what is going on there.
I have to get out of it.
What is happening?
So when they shoot it, the sun's shining on it, but when they shoot it, it hits another mirror, which hits another mirror at a different angle. So they just keeps hitting mirrors.
Exactly. So they are using one mirror to get the sun rays, but then they are lighting up the entire room based on reflecting.
angles.
Yes, exactly. So Karthik, now you play our clip. So this is what Karthik did. Karthik, play your clip. Yes. Yeah.
Stop. Mom, I think this is a photo.
How about the
no, you should be able to.
Huh?
create the photo? Next slide, please.
Oh, no, it's moving. Yeah, got it.
Full screen.
Sorry. No, I'm just
So that's a movie. This is what these guys did. Okay. You see that?
This is just something that we made up.
So they did the same thing. So you have a piece here, right? You see the hole, they punched a hole and then you use the laser light, okay? And then based on the angle, based on positioning the mirrors, you will be able to, like the way you just you simple trial and error, okay? So based on the reflection of the light, you will be able to make a star plus whatever you want to do. So do you see that? These are all mirrors. You see that? Any doubt? You get it? Or?
Next slide, please.
Thank you. Next slide.
Oh my god.
Sorry. Okay. Next step. Okay, we saw kaleidoscope, periscope.
Yes, we
We saw
saw.
the floating frog. You understood the concave and concave. Okay, one more reflection thing. So, Kriti, put up a pineapple or something. So, based on the angle, you're not going to do the math thing, but say, okay, say here. Okay? So, how many images of pineapple do you see? 3. Okay? How many do you see? Kriti, move Kriti. Now, if I close the angle, how many do you see now? 4. Now how? You see that? You see the number of reflections? Why it is happening?
When the more you move it in it gets more.
Yeah. So multiple reflections. Here you have like only 2 mirror reflection. Okay? Here no mirror reflection either in this mirror or this mirror, but then if they are converged, it reflects here. That's why you see so many. Based on the angle, you'll be able to see as many images you can get. Okay, next Kriti. What is the other activity?
Oh, we also have one more video.
Okay, Kriti, can you go back to the activities, please?
Just let him watch it.
Okay, Kriti, this video you can show in the later. Okay, can you please? Kriti. Okay, go back to that activities. Let's show the activities and then we'll come back to that. Okay. That you understood. Infinity parallel mirror we explained, right? You have 2 mirrors. The number of images formed is infinity. And then funhouse mirrors. Okay, so this is the funhouse mirror which you can see. Karthik, come here. We have gone to Navy Pier Maze, right? Navy Pier Maze. We have the full length mirrors. Say if this is you, okay? Based on the mirror, if you have convex and concave, it will look like she's bulging up with the short legs, with the long face. Have you seen that? Do you crack up?
Yeah.
So this we made a small version, doll version from this mirrors. Okay? And then what is the next one? So Foxtrot mirror ball. So again, this is the Foxtrot mirror ball. What they do is they light it up, and based on the reflection and when it rotates, based on the light, it lights up the whole room. You have bigger size, small size. In the dance floors and in discotheque, they use these things. Okay? It's mostly mirror ball. Okay, next. Heliostat, we did heliostat. And then floating head on table chair. Okay, so this. Have you seen them? Okay, so have you seen the magic shows?
Yeah.
So they say like, okay, there is a chopped head on the table, but then it moves, it talks. You see this in particular angle. Do you think the cat has a body or not? It has no body? Okay, Karthik, how do you
No, I
explain?
want to do it. I want to do it.
Okay,
Ta-da.
you see that?
We
Kriti?
didn't cut off the cat.
Okay. So do you see the cat? So what do they do in the circus and all? What do? They make the person sit on a chair or something, and then they put up a mirror here. So when you put up a mirror, what happens? You see the reflection of the. For this trick to work, you have this border and this wall has to look same. Okay? Because if this is painted in blue color and this one is in red color, then the trick wouldn't work. It has to be designed the same way. And Kriti, where is the table? Put the table up.
What sort of mirror do you need?
Plain mirror. Just a plain mirror. Yeah. So now when you use a mirror, it looks like it reflects on the front and it hides what's in the behind. So it looks like the head is floating, okay? There is another trick. They make an elephant or something disappear. Have you seen that trick? The crane or elephant disappear. So I haven't made the model, but this is how it works. So they have a door like this thing. Okay, they keep it in front of it, and then behind that they will have a huge elephant or a train or something. But then they start the smoke screen. So when the smoke happens, what they do is they tilt this. They tilt this slide, okay? So this will have a mirror. So what will happen is, see, here I try to do it. So here you have the, you won't be able to see the mirror first time when the elephant is hiding. When they put the smoke screen, they tilt this mirror. So what you do is, you see a mirror. So the mirror will reflect the side walls, okay? So when it totally tilts, you see that it kind of hides the whole thing, hides the whole elephant behind. You see that? But instead of the plain door, you will have a mirror, so it will reflect whatever is in the side. So it will look like the elephant has disappeared. This is another magic trick you can do with the mirrors. Okay? What is the other one?
So for the magic trick where like they lift people up and like they magically disappear them, what do they do for that? Do they use mirrors for that too?
I think they can use, like you can, if you put up a mirror and then you kind of like say, if you have a plain mirror, okay, and then your other leg is down, but then this leg is here, you will see the reflection in the mirror. Conceal the mirror, and this leg, you will see reflection of this leg. So it looks like I'm still having my two legs, but then they are floating. But my gravity is here. Do you understand what I'm trying to say? Like, this is the floating trick what they do. They have a huge mirror, and then the leg is. So this girl, okay, this is me. I stand behind it, okay? Say I have a table or something here, okay? I stand there, but then you see my legs floating in a particular angle, you still see two legs, but they are floating, right? But the actual balancing or standing, she is not fighting the gravity because there is a table and she's standing on that table, but she's standing like this. But in the other side, if you see this reflection, this leg's reflection will show us two legs and she will look like she's floating. That is levitation. One type of levitation they can do. That's another way. Again, I'm not a magician, so I don't know all the tricks. That's one other trick you can do it with the mirrors. Yeah, laser show. You can try experimenting based on the lights. You can make the mirror move. And then another thing, if you want to do a laser show, you can point a laser in a mirror and then make it vibrate with a speaker, huge speaker, and then you can be able to create a laser show. Okay? Any doubts? Any question? Any doubts? Okay, you can try the experiments till your mom comes and takes.